Everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist. Now this is the part of the ongoing Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Make sure you check it out. Otherwise, you're going to miss out on something extremely special. So the problem that you're going to solve today will be finding out the kth missing number. What does the problem state? It states that you'll be given an increasing array where you'll be having positive integers. Your task is to figure out the kth missing number. What does it mean? You can see that the last number is still 11. So if I start writing all the positive numbers, the positive numbers start from 1. So let's quickly write it till 11. So the moment I write it till 11, if I ask you which of the numbers are missing, you can say 2 is there, 3 is there, 4 is there, 7 is there, 11 is there. So apparently, this is the first number that is missing. This is the second number that is missing. This is the third. This is the fourth. This is the fifth. This is the sixth. And the question is specifically asking you to figure out the fifth missing number. So if you carefully see that the fifth missing number is 9. So this is what you have to return, which is basically 9. So given an array of increasing positive integers and given an integer k, you have to return the kth missing positive integer. That is what the problem states. This problem might have a lot of brute force solutions, but the one that I'm going to speak will be super easy and clean. So imagine I give you an example where the array is starting from 5 and then it has 7 and then probably 10 and then 12. And I'm asking you to figure out the fourth missing integer. What will be the fourth missing integer? Your answer will be 4. Why? Because the array itself starts from 5. Thereby, all the first 4 numbers will be missing, and since the question is fourth missing integer, I say that the number is 4. What if I ask you, what is the sixth missing integer? You cannot say straight away 6 like you did when k was 4. You cannot say straight away 6. Why? Because there is an integer 5. Thereby, the answer will be, like if I have to write 1, 2, 3, 4, 5 is there, 6, 7. So if I'm looking for the sixth missing integer, it's 1, 2, 3, 4, 5, 6. This is it. One more. So if you carefully observe, what do you observe? There was one integer which was lesser than 6. Thereby, you kind of added that and you got this particular number 1 ahead. 1 ahead because the 5 took a place in between. Hence, the 6 could not be the answer. So this is what the brute force will be. So let's quickly do the brute force on the given example. So what I'll do is I'll take the k equal to 5 and I'll start iterating. I get 2. I say that this 2 will take 1 place. So now I'm looking for the sixth possible number, like the answer can be 6. Then I'll move to the next and I'll say 3 will take 1 more place. So 7 can be my possible answer. Now I'll move forward. I have 4. 4 will take 1 more place. Thereby, I'll move to 8. Then I'll go to 7. 7 will take 1 more place. Thereby, I'll move to 9. The moment I move to 11, I see this has exceeded. So I stop then and there. And I say that this particular 9 is my answer. So this is going to be my answer for the brute force. Super simple. It's basically the numbers that are lesser than k will take its place. Thereby, you have to move. And wherever you stop, that will be your answer. It's going to be super simple. I'll just start from 0. I'll go until the last integer. And I'll say if array of I is lesser than equal to k, I'll just do a k plus plus. If I get any number, because it is an increasing order, if I get any number which is greater than k, I stop. Hence, you can straight away see break. And this is what the possible solution will be. And what will be the time complexity? Big O of n. What will be the space complexity? Big O of 1. Now, this is what the brute force solution will be. The moment you give the solution to the interviewer, he might ask you to optimize it. If you have to optimize big O of n, what should you use? Because what is better than big O of n? Probably logarithmic of n. And that does make sense over here because the array is sorted. And whenever we see something as sorted, we need something better than big O of n, logarithmic of n, that kind of gives us an idea that, okay, binary search might be a solution. This is how you get the intuition of binary search that, okay, sorted, increasing, need better than big O of n. Thereby, we move towards a logarithmic n solution. So, can we apply the typical binary search algorithm? We cannot. Why? Because we are looking for the missing number. This number is not there in the array. So, we cannot apply the typical binary search in a sorted array. So, binary search is not possible like the normal one. Can we apply binary search on answers? We cannot, because binary search on answers is only applicable when you are looking for something like minimum or maximum, and you know that some portion is not possible and the other portion is possible. So either you look for the min or either you look for the max, something like that. But over here, that's not the case. The case is very different. If you carefully notice, this particular answer 9 should have been between 7 and 11. So if I somehow can figure out between which indexes this particular answer should have been, I think my problem will be solved. So how do we apply binary search in this particular question? Can I say I'm very much sure that the answer will be between 2 and between 11 for k equal to 5. I am very much sure about that. Okay. Can I say that I'm also like, for this k equal to 5, I know the answer is 9, and that always lies between 7 and 11. I'm also very much sure about this, right? What if k is 3? In that case, the answer is 6, and that is lying between 4 and 7. I know one thing, for binary search, I take the entire range. If somehow I can figure out, like for k equal to 5, I know the answer will be between 7 and 11. If I can figure out the smaller range, I'm very much sure that it will be between 2 indexes. If I can figure out that 2 nearby indexes, my question is solved. So first target is to figure out the 2 nearby indexes. That's what our target will be. And then we will figure out how to get the answer. Once I'm standing here and once I'm standing here, I will figure out 9. I'll figure out 9. As of now, what do I have? I have an increasing array. I have k equal to 5. And what do I need? I need to make sure that I stand between, I stand on those 2 indexes between which the answer will be. So that's my first task. Figure out the 2 nearby indexes. So the next thing that you should be thinking is, hey Striver, you did know that the answer was 9. That is why it was easy for you to say that 9 was between 7 and 11. But wait, we do not know what the answer is. We are just given k and we have to find that number. So how do I figure out that it is between 7 and 11? Because I do not know the number. This is where k will come in. It will help us. Let's observe something. If I write down the indexes, this is how it will look like. Ideally, on a normal scenario, the numbers should have been this 1, 2, 3, 4, 5 in the array if nothing was missing. But over here we have 7 and we should have had 4. Thereby, can I say, till this particular index, there are 3 numbers missing. If I again write down the integers 1, 2, 3, 4, 5, 6, 7, you have 7. And before that you have 4. And before that you have 3. And before that you have 2. So you have 3 numbers missing. And how did you figure that out? It's very simple. You had 7. So you said 7 is present. Ideally 4 should have been present there. Thereby there are 3 numbers missing. I'm like, okay, there are 3 numbers missing. Over here, there's 11. So if I have to again say 11 is there, ideally what should have been there? 5 if I write down the numbers. So how many numbers are missing? Can I say 11 minus 5 equal to 6 numbers is what is missing over there? You can again go ahead and write down the numbers. You'll figure out that 11 is there. Thereby 1, 2, 3, 4, 5, 6. 6 numbers are missing. So can I say that? Can I say on the basis of k, on this index, 3 numbers are missing. On this index, 6 numbers are missing. If I can figure out the numbers of missing, what am I looking for? I'm looking for the 5th number which is missing. Thereby, can I surely say that it will lie between this? It will lie between this. If I again write for this one, if you write for 4, how many numbers are missing at 4? Ideally, there should have been 3. So 4 minus 3 is 1 number is missing over here. So there is just one number, there is just one number which is missing at 4. If I have to write it for this, Ideally, there should have been 2. So there is again 1 number missing. Ideally for this, 2 minus 1, because there should have been 1. So 1 number missing. If you carefully observe, till this particular index, 1 number is missing. Till this particular index, 1 number is missing. Till this particular index, 1 number is missing. Till this particular index, 3 number is missing. Till this particular index, 6 number is missing. And what is that you're looking for? You're looking for the 5th missing number. Thereby, you can easily figure out that between this is where it will lie. So what I've done is, I've written down the missing numbers at every index. Now can I perform a binary search in order to figure out where will the 5th missing number lie? I can. What I'll do is, I'll take the low pointer to be at the 0th index. I'll take the high pointer to be at the last index, right? So what will be my first mid? Mid will be 0 plus 4 by 2, which is 2nd index. So mid will be pointing to this place, which is the 2nd index. And over here, we notice that the number of missing numbers is 1. What am I looking for? I'm looking for the 5th missing number. So I know that this one can be eliminated because 5 is greater than this missing number. I'm looking for 5th missing number and 5 is greater than 1. So the left portion can be eliminated. So please go ahead and eliminate and move to this. So this is what I'll do. I'll eliminate and I'll move ahead. Next, what is my job? My job is to figure out the next mid, which is index is 3. 3 plus 4 is low plus high by 2. Thereby it will be 3. So the mid will be pointing to 3. This is the moment you notice that, hey, listen. Over here, we are seeing that this is having 3 missing numbers and we are looking for 5 missing numbers. So this is also not possible. So can you please, because this was already eliminated, can you please eliminate this? And at the same time, take low and move to mid plus 1. We will just move there. At the next step, mid will also be pointing to this. At the next step, mid will also be pointing to this because 4 plus 4 by 2 is 4. So the mid is already pointing to this. Over here, we have 6 missing numbers. We have 6 missing numbers, but we are looking for 5. We're like, the right has to be eliminated. The right has to be eliminated. And when the right is eliminated, high goes as mid minus 1. So we'll move high to 1 place back of mid. And this is the moment you see that, hey, the low and high have crossed. So if you carefully observe, high is standing at 3, which is lesser than k. Low is standing at 6, which is greater than k. Did you notice something? Initially, the low was at a point which was lesser. Where has the low gone? To a higher point, to higher than k. Opposite polarity comes in. Let's see, where was high? High was at 6, which was greater. Where is high ending at? A lower. Opposite polarity. So eventually, you are ending up at 2 nearby indexes. So I figured out my nearby indexes. Done. What is my next job? If my low is pointing, if my low and high are pointing to the nearby indexes, the next job is find the number. Find the number is my next job. It's going to be super simple. It's going to be super simple. Why? Let's analyze. So the high is pointing to, like the array of high is pointing to 7, right? How many numbers are missing? Can I say 3 numbers are missing? I can. So if 3 numbers are missing, how many else am I looking for? I need more 2. That's very obvious because k is 5. And till here, the missing are 3 because ideally, if I write down, there should have been 4. So the missing are 3. How much more do I need? 2. So what do you do is, he says 7. Can you go to your next number? He says 8. Can you go to 1 more? Because I need 2 more. That's 9. So 9 is your answer. So 9 is your answer. This is your answer. So what you do is, you say high plus how many more you need. How many more you need. That is what you have to say. High plus how many more you need. And this more, we'll come back and do it. Like we'll come back and find out a formula. But as of now, just remember high, like whatever is array of high. Because array of high is 7. And whatever more you need because you already have k equal to 5. And there are 3 missing numbers still here. So more will be 2. So that's what you add it up. That's what you add up. Again, if I have to give an example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is here, this is here, this is here, this is here, and this is here. So this was not here, this was not here, this was not here. So 3 were not there. Until here, you got it. So the next two numbers which are not there will be 8 and 9. Thereby, you just add the more numbers that are not there. Okay, so you have got array of high plus more is what you have to do. Got it? We'll try to figure out a formula so that we are not dependent on the value of array, and we will do that afterwards. But let's quickly write down the binary search code. Where am I starting the binary search at? So at first, so let's write the array, and we're looking for the k missing number. So let's just write it. I'm starting the binary search at the 0th index, and I'll go till the last index, which is n minus 1. That is very much sure. Let's quickly do the generic binary search, which is low, lesser than, equal to high. Again, the standard low, lesser than, equal to high, and everything will be standard. No changes in that. I'm trying to keep it consistent so that you understand the concept in a much better way. What's the next job? Finding out the mid, which is low plus high by 2. Right? What is the next job? How many are missing? You have to figure out how many are missing, because on that basis, you either eliminate left or you either eliminate right. How many are missing? Can I say array of that mid index minus what should be there originally? Because if I'm having 7, originally it should have been 4, which is 1 plus index. Can I say 7 minus index plus 1 will be the missing number? Can I say this? Because 7 minus whatever is the index plus 1 will be the number of missing number. I can. Thereby, I'll write this as array of mid plus 1. That will be my missing numbers. If missing is lesser than k, then I'll eliminate the left half because I'm looking for the range. Or else, I'll eliminate the right half. Quite simple. Done. Done. Now you have to return array of high plus more. But we'll try to figure out a formula for this, because array of high might not be correct. Why? I'll tell you. Imagine your array is given as 4, 7, 9. And I'm looking for k equal to 3. So where will the high point to? This will be here, because third missing number will be somewhere before 4. Before 4. So the high will be pointing here and the low will be pointing here. So high will be pointing to negative index. So array of high cannot be written. Just take this example. Try to do the binary search. Try to do the binary search and see where is high ending at. You will see that high is ending at the -1 index and the low will stay at the 0th index. Because this is where the third missing number will be. This is where the third missing number will be. So you cannot say array of high plus something. So we have to figure out a formula for this. We will do that now. Okay, so let's figure out the formula. At array of high, because if you remember this particular example, high was standing at this and low was standing at this. So at array of high, we had 7, right? And the missing numbers were 3. What is the formula for missing numbers, if I ask you? It's array of high minus that index plus 1, because that is what it is. 7 minus 3 plus 1, sorry, 3 plus 1. That's 7 minus 4 equal to 3, because ideally there should have been 4 here. So we know the formula for missing is this. How many more do you need? That is what the thing is. What is your answer? Array of high plus more. What is more? What is more? Can I say more is nothing but k minus missing? Can I say more is nothing but k minus missing, because k was 5, missing was 3, so more came out to be 2. Whatever you are looking to find and wherever you are at, k minus missing will be your more, right? So can I say this was my answer? This was my answer, which is answer of high plus more. So I'll write array of high plus more. What is more? K minus missing. K minus missing. What is missing? Array of high minus high minus 1. What I've done is I've simply put values. K minus missing was more. In missing, I've put this value. This will go here and this becomes this. Perfect. Now what will happen? Array of high plus k minus array of high plus 1. So array of high and array of high will go off. And the formula turns out to be high plus k plus 1, or I can say high plus 1 plus k. This is what the formula turns out to be. This is your missing number. Or you can say, we know one thing for sure, low is also high plus 1. Low is also high plus 1 if you carefully notice, because low is one place ahead of high, so low is also high plus 1. So either you can return this, or you can go ahead and return low plus k as well. This is the reason in a lot of solutions you'll find low plus k being returned, and in a lot of solution you'll find high plus. Actually, you will not find in any of the solution this being returned. Everyone is returning low plus k, and no one is explaining the reason behind it. The reason is this derivation. I hope you have understood this. So let's quickly go back to the code, and over here we will return high plus 1 plus k, or else you can return low plus k as well. That is your choice. Either this or either that. That's it. Done. What is the time complexity? You're doing a typical binary search in the array. So it's a big O of n. What is the space complexity? A big O of 1. And this will also be running for this example 4, 7, 8. And I'm looking for the third missing number. So since you know that at the end of the binary search, high will be pointing at the -1 index and the low will be pointing at the 0th index. So there is no array of high because it's an array of negative index. So you do high plus 1, which is -1 plus 1 plus, if you remember, it's k. So you do 3. So the answer will be -1 plus 1 will be 0, and the answer comes out to be plus 3, which is indeed your answer. This is why I converted it into a formula. I could have written array of high plus more, but that is technically not feasible for such cases where the high ends up pointing to this place. Got it? So let's quickly get back into the code editor. By the way, you can find out the problem link in the description, and you can also find out the C++, Java, Python and JavaScript code links from the description as well. So this is how the code will look like. You can return k plus high plus 1, or you can also return low plus k. That is your wish. So I have submitted this code and it works. And if you're still watching, I hope you've understood everything. And in case you have, please do consider giving us that like. And if you're new to our channel, do consider subscribing as well. And yeah, if you haven't followed me on Instagram, Twitter and LinkedIn, all the profile links will be in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.